Yeah, let's cover lesson 12, mathematical expressions. Okay, let's recall what a variable is. A variable is just a symbol. A symbol. It's usually a letter. And it stands for a value. Now, the value can change. It stands for a value that may vary. It may change. Value that may vary, hence variable, or change. All right. An expression. Now, an expression is a combination of numbers and variables. And using operations like addition, subtraction, multiplication, division, exponents, working backwards here, and parentheses. The one thing it does not have an equal sign. So make a note for an expression, there is no equal sign. Okay. Translating words into mathematical expressions. Okay, so we're going to be doing a lot of word problems in this section. Based on what I'm seeing here. Translating words into mathematical expressions means translate the following phrases into mathematical expressions. So what you're going to see here is 12 larger than X. So assume you have some number X. All right. But there's another number that's 12 larger than X. And what that means is X, that means that you're going to add. Larger than means you're going to add. So you're going to that X, you're going to add 12. And it has to be in that direction. And you'll see why when I go to the next one. The word than, I always think in my head, it means flip in front. So that just means the variable comes in front. So 12 is larger than X. So 12 more than X, 12 larger than. You're going to add 12 to X. If it's 11 less than Y, so that means you have some number Y that is 11. There's some number that Y is, you're going to subtract 11 from, and that's what it is. So Y minus 11. So less than means subtract. Okay. And then the last one here is R decreased by, and that is R decreased by 9. It decreased by means subtract as well. Okay. How about something like 20 decreased by 9? So 20 decreased by 9 would be 20 minus 9, which is 11. Okay. So word problems. Let W represent the width of the of the rectangle. The length of the rectangle is 4 feet longer than its width. Express the length of the rectangle in terms of its width. So if that's the case, we've got a rectangle and W is the width. So this is our width of the triangle. And we got the length of the triangle. So the length of the triangle is equal to, so length of the rectangle is L. The word is always an equal sign. 4 feet longer than. Well, longer than, larger than means we're going to have plus 4. So 4 feet longer than the width. So width plus 4 is the length. So width is here, and the 4 feet longer than goes the plus 4. Okay, so I couldn't make that. I don't want to cross over the lines. Okay, so what does that mean? Well, L is equal to W plus 4. That's what we're looking here. There's one more thing I want to do to this. I don't know if I want to do it here, if I want to do it coming up. How long is this lecture? It's a little bit long. Okay. I'm going to keep going. So that's all we need to do there is just W plus 4. That was my answer. A string measuring 15 inches is cut into 2 pieces. All right, so I need to draw this. I need to visualize it. So a string from here to here is 15 inches. All right. It's cut into 2 pieces. Let's just say it's cut right here because I don't know. Let X represent the length of one of the resulting pieces. Okay. Express the length of the second piece in terms of the length X for the first piece. Okay. So if I know the whole thing is 15 and I'm saying this one little section is X, how do I know what the other section is? Well, it has to be 15 minus X. It has to be this whole thing minus X. So this piece is 15 minus X. The length of the whole thing, but minus that one section. Okay, we can now, that's all we needed actually, isn't it? That's all they wanted to know. Express the length of the second piece. Yeah. So let's just say that this piece was 4 inches. Well, then how much is the other piece? It's 15 minus 4, which would be 11. All right, so all they wanted us to do was express the length of this piece, second piece, in terms of length of X. So 15 minus X. All right. Next one. We are talking about, oh, this is going to give us a lot of really good things to work on. This is great for your arsenal for word problems. So let's just do some translation here for what these things mean. The tables below are not exhaustive. That means not showing everything, but it shows common phrases that we will be translating. So for the phrase, the sum of X and 12, that's just X plus 12. Sum means addition. So make sure in your vocabulary, you know that sum means addition, S-U-M. 4 greater than B, that means that B plus 4, you're adding. 6 more than Y, that's Y plus 6. More than is you're adding. 44 plus R is literally 44 plus R. 3 larger than Z, so Z plus 3. Okay, these are all phrases that are sums, so addition. Addition. The next one are phrases that are differences. Differences are subtractions. So difference of X and 12 is X minus 12. It's not 12 minus X. The X comes first, so therefore the X comes first here as well. 4 less than B would be B minus 4. Even though the 4 is coming up first, this is one of the ones that I told you, whenever I think of than, I have to flip it and move it to the other side. All right. 7 subtracted from Y. Well, that's Y, and they're subtracting 7 from it. 7 subtracted from Y. 44 minus R. 3 smaller than Z. So if you have a Z, it's 3 smaller than. Okay, there's than again, it flips it. And these are phrases that are product. Product means multiplication. Multiplication. All right, product of X and 12, that's just X times 12. Or you could write 12X. 4 times B is 4 times B, or 4B. Twice R is 2 times R, right? Or you could do 2R. Phrases that say Phrases that say different? No, that are differences. Oh, more differences. Phrases that are differences. That's weird. All right. Quotient of x and 12. Quotient means divided. These are all divisions. These are all divisions. I don't know why they wrote differences. So quotient of x divided by 12, not 12 divided by x. 4 divided by b, 4 divided by b. The ratio of 44 to r, 44 to r. These could also be written as x divided by 12 or x divided by 12. You could all write them all the same, just in case, you see something different. They could all be written this way as well. Okay. All right. A plumber has a pipe of unknown length, x. He cuts it into 4 equal pieces. Find the length of each piece in terms of the unknown length x. Okay, so we've got a pipe. All right. And they're saying that the length of the pipe is x. And then they're cutting it into 4 equal pieces. So 1, 2, there we go, 1, 2, 3, and 4. Find the length of each piece in terms of the unknown length. Well, if this is x, and this is x divided by into how many pieces? X divided into 4 pieces. All right, so that's what this is. This is x divided by 4, x divided by 4, x divided by 4, and x divided by 4. Check this out. If I add those all up, which we haven't learned fractions yet, but when you do that, that's 1, 2, 3, 4. That's 4 of them over 4, which is an x. So all we need to know, you don't need to know all that yet. All you need to know is that the answer is x divided by 4. Okay, that's what each piece is worth. All right, the next one says Mary invests $8 in a savings account, paying 2% interest per year. She invests 5 times this amount in a CD, a certificate of deposit. It's just a way to save money, paying 5% per year. How much does she invest in the CD in terms of the amount of A in the savings account? All right, well, let's start saying what they have here. We've got a savings and a CD. It's 2 different ways to save money. The savings, she invests $8 in. Okay. She invests 5 times that amount in the CD. Well, 5 times what? 5 times the amount that she invested in this one. Well, she invested A in that one. So how much does she invest in the CD? She invests 5A, 5 times however much she put in the other one. Okay, I don't have a number, so I can't really put a units or anything, but that's what they're wanting us to do. It's 5A. Let the first number equal x. Okay, we got a couple numbers here. So we've got a first number. I'm assuming we're going to have a second. So the first number equals x. All right. The second number is 3 more than. 3 more than. Okay, so that's plus 3. And then it says twice the first number. All right, so I know I've got the plus 3. But it's twice the first number. Well, the first number is x. So twice something is 2 times it. So 2x plus 3. So 3 more than twice the first number. Cool, got it. So 2x plus 3 is the second number. All right. Next one, the length of a rectangle is L. Oh, I need to draw this one. The length is L. The width is 15 feet less than, 15 minus 3 times the length. Well, if the length is L, so it's 3 times L. 15 less than 3 times the length. There is the width. Cool. That was fun. Okay. To evaluate an expression for a given value means, well, we're going to replace all variables. There's three things here. One, we're going to replace all variables with parentheses. Oh, out of pen. Keep running out. Gosh darn it. Here's. All right, we're going to replace all variables with parentheses. We're going to leaving room inside the parentheses. Leaving room inside the parentheses. Ooh, this writes nice. I'll show you. Number two, we're going to substitute the given values. We're going to substitute the given values into the parentheses. And then the last thing, we're going to evaluate using the order of operations. And remember, that's PEMDAS. All right. So note that this is not the same as solving an equation. All right, we're going to evaluate the expression. So we're not solving for anything. We're going to replace the variables with parentheses, leave them blank. Then we're going to fill them in. So the first thing I'm going to do is I'm going to rewrite this. I've got x squared minus 2xy plus y squared. So I've got an x squared minus 2, an x and a y plus a y squared. All right, I've replaced all of the variables with parentheses. Now I'm going to take what they're telling us. Everywhere there was an x, I'm going to plug in a -3, and everywhere there's a y, I'm going to plug in a 2. I'm just substituting. So this was an x, so now it's -3. This was an x, -3. This is a y, so it's 2, and this is a y, so it is 2. Now that we've substituted, the last piece here is just evaluate. So -3 squared is -3 times -3, which is 9. And then we've got -2 times -3. I'm just going to bring those down. -2, -3, 2. I'm going to do my exponents first. Plus 2 squared is 2 times 2, which is 4. All right. I can't do anything with this 9 right now. -2 times -3. Negative times a negative is a positive. 2 times 3 is 6. I'm going to bring down that 2. Now I have to do the 6 times 2. I need to bring this over here. I'm going to bring this up top. So 9. 6 times 2 is 12 plus 4. 9 plus 12 is 21. Plus 4 is 25. Okay. All right. Evaluate the expression a minus b squared. So I've got an a minus b and squared. All right. The a was 3 and the b is -5. So now I've got inside the parentheses 3 minus -5. I need to change these signs. So that's 3 plus 5. 5 plus 3 is 8. Squared is 8 times 8. And that is 64. Okay. A couple more. Absolute value of A. I'm just going to leave absolute value minus absolute value of B. And that's all we have. So A is 5 and B is -7. Absolute value of 5 is 5. just anything that comes out of an absolute value is positive, minus, just going to bring this down. The absolute value of -7 is the +7. Now we've got +5 minus 7. The signs are different, so we subtract them and take the sign of the larger number. Our answer is -2. Okay, the absolute value of A minus B. We need to put some parentheses, I guess, in here to fill these in. So A is 5 and B is -7. All right, I'm just going to redo this. I've got 5, negative and a negative is going to give me +7. So now we have an absolute value of 5 plus 7, 8, 9, 10, 11, 12. And the absolute value of 12 is just 12. Please let me know if y'all have any questions about this. Only a couple more to go. All right. Evaluate the expression at at A equals 5, B equals -3, C equals 2, and D equals -4. All right, so I'm going to put parentheses for these. So we've got an A times D minus B times C over A plus B. All right, so A is 5, D is -4, B is -3, C is 2, A is 5, and B is -3. All right, I've got my numbers plugged in there, substituted, and the last piece of this is I'm going to evaluate. We've got the multiplications that we're going to do first in the numerator. So I've got 5 times -4. Well, 5 times 4 is 20. Signs are different, so it's negative. All right, minus negative, we got 3 times 2 is 6. A negative times a positive is a negative. And now down here, we've got 5 plus -3. Oh, well, the 5 plus -3 is just 2. You subtract them because the signs are different and you take the sign of the larger number. And then the last one up top is -20. A negative times a negative is a positive. All right, over 2. And I'm going to bring this up here. -20 plus 6. The signs are different, so we subtract and take the sign of the larger number. Just bring it up here. Over 2. Now we divide. 14 divided by 2 is 7. The signs are different, so it is a negative. Okay. Now for our word problem. Picture below is a rectangular prism. The volume of the rectangular prism is given by this formula. Volume is length times width times height, where L is the length, W is the width, and H is the height of the rectangular prism. And it says find the volume of a rectangular prism, and then it gives us the length, the width, and the height in numbers. So we've got volume is length times width times height. And here they're telling us that the length, I'm going to just replace these with 12 feet for length, so 12. The width is 4, and the height is 6. All right, so the volume is 12 times 4 is 48 times 6 is, let me do that, 48 times 6 is 8. 4, 5, 6, 7, 8, 20 is 288. So volume is 288, but the word problem, so we've got to make sure and put at least represent what it is. Volume is always measured in cubes, so the volume is 288, and it's feet times feet times feet, so it's feet cubed or cubic feet. And that is it for lesson 12. Let me know what questions you have, and I'll be back with lesson 13.